Alright, hello everyone. Today we'll be talking about word search 2. This is 212 of the Leetcode problem set, and the description states that given a 2D board and a list of words from the dictionary, find all words in the board. Each word must be constructed from letters of sequentially adjacent cells, where adjacent cells are those horizontally or vertically neighboring. The same letter cell may not be used more than once in a word. So let's take a look in Microsoft Whiteboard. Right now I took their input and output case and copied it here, and I marked out the path that you will want to take to construct the given words. So right here, as you can see, they gave you a dictionary, and then they also gave you this matrix. So, and they asked you to find all the words that you can make in this matrix that are also in this dictionary. And as I've marked out here, it's eat and oath. So this question also asks you to output it in a list. However, the list doesn't have to be in alphabetical order. The output example says alphabetical order, but it's fine if it's in any order. So it says adjacent cells means vertically and horizontally neighboring cells, which means if we're going to index the moves, we're going to have 4 potential moves that we need to make. So one is I doesn't change, but J gets decreased, or I doesn't change, J gets increased, or I gets decreased and then J stays the same, or I gets increased and J stays the same. So say you have a grid right here. This is where you're at. Then these 4 grids are the grids that you need to go to. So this one, this one, this one, and this one. Then you will just use these 4 moves and then go there. That's how you would construct the strings as you go. And the solution to this problem is backtracking. However, backtracking and searching for all the possibilities on the 2D matrix would be way too slow to pass the bigger test cases. It will pass the smaller test cases, but when you get bigger, it will time limit. So instead, we need to implement a try class and quit if the prefix doesn't match with each other. This will reduce the search volume by a lot and allow it to run fast enough. So now some of you might be wondering what a try is. And let's move on to this place. So try is a structure that holds, it's a structure that holds it can tell you whether a prefix of a string is, whether your prefix is in the string that you gave it to. So for example, this will make more sense. I have an array of words, and I want to transform this array into a try structure. And right now there are 3 words inside the array: apple, eat, and apply. Right now what would happen, what a try class would do is make this kind of n-ary tree. So there's going to be no root, but each child will have a string of its own. As you can see right here, that's apple, and then split off here is apply, and then this single branch is eat. So this is what a try structure is. There are 2 very important properties. One of them is that it should store all of the prefixes of the words. The other one is very important. It should store where the word ends. And then a try class would also check for prefix of a word. This should be of. The and the time complexity should be constant, O of 1. So this would allow our program to run fast enough to pass the faster test cases. So we're going to take the idea of a trie, but instead of actually making a tree, we're going to use sets to add the prefixes into. And it'll also be O of 1 time, just that it'll be a way easier implementation. So what we're going to do is, for this word apple, if we're going to say apple, I'm going to add a to the prefix, ap to the prefix, app to the prefix, appl to the prefix, and apple to the prefix. So that's just a prefix for apple. For eat and apply, the same applies. And then I'm also going to have a word array that stores the whole words. Basically, it has the same function as marking where it ends. So I'm also going to store apple, eat, and apply in a separate word set that tells that allows us to know if the word is complete or if it's incomplete. And that is basically the same as a trie class, way easier in implementation, the same time complexity. Now let's head over to Leetcode and write the solution. The first thing I'm going to do here is write our trie class. I'm going to call it trie. So inside, I'm going to have two sets, as I've previously stated. One is the word, and then one is the prefixes. Now, the standard way would be to just declare these as instance variables and then make a constructor. So let's be standard and make a constructor. In the constructor, I will ask for it to pass in the string array. And then what we're going to do is we're going to start inserting these things in. But instead of this, we could just make it simpler. I'll make an insert function afterwards, and we'll just call insert and insert the words separately. So let's do this the correct way and instantiate our our structures inside. And then I'll go delete these. Alright, so that's our constructor. Now let's make our insert function, where it will insert the prefixes and the word into the two structures respectively. This will take in a word as the parameter. I should probably make it words because one of my set is called word. Here you want to avoid this as much as possible because it gets confusing after a while, which variables which. So I'm going to name this one words. And here we need to add words to word. And we don't need to worry about repeats because sets take care of that automatically. And then what we need to do is we need to add all the prefixes into our set. And we can do that with a very simple for loop. And then I'm gonna set this to be smaller than equal to because we're going to use the substring function. And substring function for the second parameter, it is exclusive, which means that we essentially need to go over one in order for it to take into account the whole string. Now I'm gonna add each prefix to the preset. So from 0 to I. That will be it. This is going to be the finished insert class. And now we need a search class and we need two search functions. One is to search for the prefix. Let's just call it starts with, and then give it a string prefix. Now all we need to do is to return whether the pre contains this prefix or not. If it does, then it will return true. If it doesn't, then it won't. The second function is search, where you want to search for a word. And here you just, and again we need to change this to words to avoid using this. And you just return whether a word contains words. If it does, then it'll return true. If it doesn't, then it won't. Here we're going to declare a few global variables. Because I'm going to make my DFS a void function, what that means is, and this needs to return a list string, so I'm actually just going to make a global list string called res, which I will return after it gets filled by the function. And I'm also going to declare a set of to see if the word repeats. And I'll get into this as we progress, why I need a rep here. Also, I need a trie, the class that we made. I'll call a prefix here, and it'll be equal to new trie. In addition, I'm also going to add a new global variable that's basically the same as board. What this will do is it will allow me to not pass in the board parameter when I'm calling the DFS function. Right now, I'll just call it gboard for a global board. And then inside the function, I'll set it equal to board. Now we're going to insert all of the strings inside of this array into the trie class. And how we're going to do that is we're going to use a for each loop. And let's just keep this on the same line. Prefix dot insert word. And that'll be it for inserting the words into the prefix trie. What we need to do now is we need to write our DFS function. As I stated here, we're going to use these for moves. These for moves are very important. Pay attention to those. Alright, let's start writing our code. This is going to be a void function called DFS with an int I and an int j for row and column respectively. And we also need a string to store our current string. Or in more formally, it's a place to store what we've constructed so far in the 2D matrix. And as every DFX function in a 2D matrix, you need to check whether your variables are out of bounds. So we need to do that first. If it is, then quit. Secondly, there's a very important line here. The same letter cell may not be used more than once in a word. It means we either need to create a memo of visited, or we can mark the letters that we've visited a different letter. In this case, I'm going to choose to mark the letters that we've visited in a different letter because I don't want to use too much memory here. So there's a note here. It says all inputs are lowercase letters. which means technically if I change any of these letters to an uppercase, we can decide if it's visited or not. So here I'm actually going to say that if the board value at I and J is equal to capital A, capitalized A, I'll say that's the letter for visited, and I'll quit. Then what we're going to do is remember what I said here. We need to quit if the prefix doesn't match with each other. By each other, I mean if the prefix that we're constructing is not in the prefix constructed in the trie class, then it's no use and we'll return. So if prefix, and remember prefix is this trie's name. So if prefix dot starts with the store, oops, if that doesn't start with it, then you don't want it, so return. We also, after this, we need to add our current letter to store as usual. So we need to add gboard at I and J, and because it's a chart, we're going to add an empty string at the end. Then we're going to see if prefix dot search, and remember search here is just seeing if the word is complete or not. If it is, it will return true. So if search store, then we want to add it to the res list. But before we do that, we need to take an account of repeats. And after I write this code, I'll tell you why we have to take an account of that. So that's just, yeah. I'll put it here. And rep, remember that's our set for repeats. Dot contains store is false. Then we'll add the word to rep, and we'll add the word to res. Okay, so let's go over why we need this rep thing here. Right here, in this case, whoops. In this case, you wouldn't need it. But say there is two configurations where oath can occur. So oath can occur this way, or oath can occur this way. And in this case, it can do it this way or that way, and I'll add it to the list twice. Now you could remove all the prefixes out of the prefix trie structure, but that would take some time, and we don't have that much time, but this will take time too. But in order of implementation, adding a rep set will be way easier. So that's what that's why we have a rep hash set here. Now we need to get the chart temp. Because this is backtracking, we need to backtrack to the original state of the array, which means we need to get the current state of the array so we can backtrack to it later. And I'm going to mark this as visited, which as you can remember is capitalized A. Then it's just DFS function calls. I'm going to copy and paste this call 3 more times. And just change the function call, the parameters. Now you could make an array that holds like the moves, and then you could just use a for loop to do that. But right now we're just gonna take an extra 4 lines and list it out by ourselves. It's not horrible. And then now after all the things gets called, we're going to return it for the next time. Store will be equal to store.substring. Technically we don't need this, but it's just better to have have it there just in case. That's it for our DFS function. Now, all we need to do is traverse through our board and see if there are any cases that result in a successful word. So let's make our nested for loops that traverses the board. A++. Okay. Now, one very important thing is you only want to search if the first letter, if say we're at 00, if this letter is the first letter of any of these. In this case, it is, so we're going to search. And because O is a prefix of oath, all we need to do here is if prefix dot starts with word at I and at J plus empty literal, then we can run the DFS. J and then empty string for the stored. And that's it. At the end, return res. See if it works. Looks like I have a compile error in line 10. Oh, it looks like I made a mistake of words, which means that's there too. There we go. Looks like it's good. Let's go submit and then see if it passes. Looks like it passes. 60 milliseconds, faster than 34.15%, so pretty good. I'm guessing they used a trie structure there. Let's take a look. Yeah, so they used these nodes, which makes it a little faster, but in terms of implementation, it's a little more complex. But that's how you do word search 2. If you enjoyed the video, please give it a like and subscribe to my channel. For more backtracking videos, you can go to my panel page or go to my playlists and check out those. If you want to see more Leetcode problems, then also go to my channel and check out those videos. And that be it for today.